My name is Lee. I come from EDDI Systems, and we've made an electro-dialysis desalinator for irrigation. During a drought, we found that farmers had a lot of problems with salinity in their irrigation water. So what we wanted to do was provide a way for farmers to take the salt out of their water before they irrigate their farms in order to save them water and increase their crop yield. What we have here is an electro-dialysis machine. I'll walk you through the plumbing a little bit. So the input is down here. This is the master valve. It controls whether there's water flowing through the instrument or not. After that, we have a salinity sensor back here. It measures the incoming salinity so that we can compare what the salinity out with the salinity in, and we can determine how efficient the machine is. After the sensor, it flows into the machine. Here you can see there are several layers here. So what's going on is the water is flowing from this side to this side. And while it's flowing, there's a positive and a negative charge on these two plates. And when you do that, the sodium ions go toward the negative side and the chlorine ions go to the positive side. And ordinarily that's usually called electrolysis. But oftentimes in electrolysis you have redox reactions going on. There's hydrogen gas being made, oxygen gas being made. It's not the cleanest environment. So to combat that, we have these ion exchange membranes. And what they do is they make sure that the ions are coalescing into every other layer. So when you do that, you get half of the layers with salty water and the other half of the layers with clean water. So this clean water, it flows through the device into another salinity sensor, and that salinity sensor measures how well the desalinator is working. So after that, it flows to the outflow, and the salty water, it gets recirculated and recirculated, and it picks up more salt as it goes in through each layer. At some point, that salty water gets too salty for the machine to actually work correctly. So when that happens, we turn on the dump valve, and we put it into an evaporation tank for water evaporation and proper disposal. Here we have the circuit box. Everything electronic is going on here. You have the ARTIK 10 board right here on the bottom. There are certain times where we have to switch the polarity, so we wanted to use the ARTIK 10's powerful GPIO pins and fast processor in order to gather sensor materials and figure out what to do based on what the readings are saying.